All right. Hey guys, welcome to our final lecture. This is going to probably be a pretty long one. We're going to break this up into different parts. And what we want to do is we want to accomplish as many things as we can with our ship shooter game. So let's dive right in. The first problem that we're trying to solve is our hit detection. So we want to be able to detect when a laser hits an enemy. Now, we explored this in class a little bit, and we were hitting some problems with trying to figure out the conditional statement to get us to the point where this point, which is the point on the laser, is within the box of the enemy. And we talked about how the 2 points really are living right here, but we need to have this bounding box. Now, luckily, there is a function in P5JS that will allow us to compute the difference between 2 points. So if we can compute the difference between here and here, right? How long is this line, basically, right? Is this line 10 pixels, 20 pixels, whatever it is? And if we compute this line and then the line falls within this space here, then we know we have a hit. So luckily, we don't really have to do much in terms of the conditional because I was digging around in the P5JS reference and we have this function called dist. And this calculates the distance between 2 points, which is exactly what we need. So if we look at the reference here, it takes in a couple of parameters, really x1, y1, x2, and y2, so 2 points, and it will return to us the distance between those 2 points. Perfect. So if we go back to our code here, and we have a bunch of stuff going on in here. What we were doing last time, we were in our draw function, and inside of our draw function, we have this. And you know what? Before I do this, let me go ahead and grab this code. I'm gonna post this to the course so you have this exact version before I start modifying this. So this will be updated. By the time you see this, it'll be updated within the course with that same link. So instead of doing this conditional statement here, which is inside of where we're looping over every enemy, we're now looping over every ship. I'm sorry, every laser in the ship. And now here is where we can check the distance between a laser and the enemy. And we can use I could type today or spell the enemy. Okay. So how do we do this? So first, we're going to need a variable that stores that distance. So we're going to go ahead and say var dist. We'll call it distance because the dist function is called dist. And now we're going to call dist, and it's going to have 4 parameters here. The first will be the enemies. So enemy sub I dot x position, and then enemy sub I dot y position. And then the second point is going to be the laser's x and y position. This is going to be laser sub j dot x position. And then I'm going to copy this because I am a lazy programmer and I don't want to type it. Y position. So let's just take a look at this. So we've got dist, enemies sub I, x position, enemies sub I, y position, ship.lasers sub j dot x position. So pay attention to the syntax here. There's a lot of dot notation happening. There's a lot of sub happening within the arrays, right? We're doing sub I and sub j. So this is somewhat complex. We're referencing 2 different lists, 2 different arrays for us to get this distance. But luckily we have this distance function, which makes it a lot less complicated because we don't have to futz around with these conditional statements. This function is essentially doing it for us. Now, this distance variable, once this runs, should contain some type of integer value that represents the distance between the laser and the enemy for all enemies and for all lasers. So let's go ahead and run this. And let's open up our console and let's just make sure that we are in fact getting a distance. So there we go. Look at the distances. Let me get this out of here. Our distances are all computing here. And you can see they're getting larger and larger because those those lasers are just going up and up the screen. So they're way in space right now, and they're just going to go up and up. They're getting further and further away from all of the enemies that are on the screen. Okay, awesome. So the task here should be pretty simple. All we need to do is check to see if this number is small within the actual space of an enemy. So say whatever the width of the enemy is, which let's take a look at that. The width of our enemy, if we go down to our enemy's class, we hard-coded this as 100. So our enemies are 100 by 100. Now we're going to probably have to modify this in the next part of this when we drop in our assets. But let's go ahead and go back up to our draw method here, and we're going to say, hey, if the distance, so if the distance between the laser and the enemy that we're looking at is less than 100, then we're going to say this dot, well, not this, we're going to say enemies sub I dot alive, remember we created that alive property, is equal to false. And now that should essentially remove the enemy from the screen, because in our enemy class, if we go down here, whenever we draw the enemy, we're checking to see if the enemy is alive. And if it is, we're going ahead and drawing the enemy to the screen. If it's not, we don't do anything. The enemy still exists, but we don't draw anything. So let's go ahead and see how that looks. Flying around, we're shooting. We didn't hit any enemies there. Let's try to hit this bad boy. Boom, we hit him. Let's hit this guy. Boom. Oh, it's gonna travel through, so our lasers keep going, and they're just gonna kill all the enemies that are right in its path. Ooh, that was a little off there. So let's see if that should not hit it. Ooh, okay, that did hit it. So we may want to constrain this a little bit, but before we do that, I would call this a success. This is working. So our lasers are hitting our enemies. Excellent. So let me pause there for a second. This is the point of getting to our hit detection. All we had to do is within the draw function, so all the way up here, our draw function where we loop over enemies, we're doing this piece right here. So let me go ahead and zoom out slightly so you can see the entire thing. You may want to pause on this piece. This is in the draw function of the ship shooter program. And this is really the code that we're highlighting. This is our hit detection. And what happened was we were able to kind of abstract this a little further because we had this distance function in P5.js, which gave us the capability to do this. So you know what I'm going to do is I'm going to grab this link, and I'm just going to go ahead and paste this in here, the reference to the distance function. Okay, awesome. So now we're at the point where we have the hit detection. We have our enemies drawn to the screen, and they're disappearing when we don't want them anymore. Let's go ahead to the next part of this. Before I go into any of the extra credit stuff, let's go ahead and drop in some assets. So I was doing some searching, and every semester I try to use different types of assets here, and I found an asset set from a talented pixel art designer, this guy here on Twitter, and there's nothing more I like better than supporting some independent developers, and really just to kind of promote to you guys too the fact that you can do this stuff now. You can get out there, you can create programs, you can create images, and you can share them and sell them to folks on the internet. So what I did was I took this off my history here. I want to go ahead and show you guys this page. So let me go ahead and pull this up. Here it is. Let me pull this. So I found this on itch.io, and I purchased it for $7. And I'm not suggesting that you do this, but I could share some of these too. I'm sure the developer would be fine with that. I may even reach out to them and let them know I'm using this. But this attracted me because it had a bunch of the animation pieces. So making it so that it's tilted on its side. That'll be part of the extra credit. We'll see if we can get to that in this video, but really I wanted to get some nice pixel art ship images. So I downloaded this, and let me go ahead and pull up. It included all of these assets. So we've got things like different planes in different states. So we have a normal and power up. So if we dive into these, you can see we have all these different images here. And if I go ahead and open one of these, I'm using GIMP, which is an open source kind of Photoshop. And you see these images are looking like this. They're really cool looking. I'm digging them. And there's a bunch of different really cool pieces to this set here. So we've got 9 different types of planes to choose from. Some of them are really cool looking. And they're all transparent PNGs. They are all, how big are they? They're 96 by 96 pixels. So that's around the size that the rectangle, I think the rectangle that we're drawing, or the triangle I should say, is, how big is the ship we're drawing here? Where is our ship? Here it is. Okay, this is actually a little smaller, so the ship's going to be a little bigger. We may want to scale this down a little bit, but let's give it a shot. Let's see what we can do. So the task here now is to get some images into our program here so that we're not just drawing just a triangle and some squares and some lines. We're going to go ahead and make this look like an actual video game. So how do we do this? Now that we have these images, and I suggest that you either use your own art or find some art on the internet. I will post some links to these images if you do want to use these just for the assignment purposes. But let's go ahead and see how these work first. So in addition to some of the ship information here, they also have things like projectiles. So these may need to be modified a little bit to support in our game, because it looks like these images have 3 different states in one image. So we'll play around with this a little bit. But I'm hoping that this kind of like gets you guys excited a little bit on how you can see how you can create images and create artwork and then apply this artwork to your own games that you've created yourself. So you can see here that, you know, this is one of the lasers. So we may want to just chop out one of these and use it for the laser. So what we'll probably do is use one of these planes for our main character, and then one of them for our enemies. You'll even also have an explosion here. Awesome. So there's some explosion stuff going on here. Different frames of the explosion. Ooh, we can get pretty crazy here, guys. So let's go ahead and let's just try to use plane 1. And I'm going to try to use one of these images. So the first thing we're going to want to do is find the image you want to use. And then in our environment, I'm going to go ahead in our images directory here, right where we put our DVD logo. I'm going to grab the image I want to use. So I'm going to grab this first one here, and I'm going to drag and drop it right into the images folder. And now we have our plane underscore 01A spin-1.png. Awesome. So now this is going to be pretty simple, but there's going to be a little bit of code we need to write here. So let me make sure I'm getting my screen all right. Good. Okay. So do you guys remember what we need to do to load up images in P5.js? We did this in the DVD logo project, and we did it using this preload function. So remember, we want to preload our image assets so that we can make sure that they're downloaded fully so that we can use them in our program without, you know, load times and things not showing up on screen. So this preload function enables us to download those images and kind of block the program from running any further until all of these images are downloaded. So what I'm going to do here is I'm going to create first a variable to store the ship image. So we're going to say var ship image, and that's just going to be blank for now. And then we're going to go ahead and define a function called preload right at the top. And in the preload function, we're going to say ship image is equal to load image, and we're going to give it the path to the image. So remember, the path to the image is going to be relative to where the shipshooter.js file is. So in this case, it's right in the images folder, which is going to be images/planes_01a_spin-1.png. Now you can simplify this file name, because if you make one mistake here with these underscores and dashes, it's obviously not going to work because it's not going to find the image. So that's looking good. I'm just comparing it to what we did previously just to make sure that it's jiving, and that's looking good. So at this point, we're not going to see the actual ship image just yet, but it is loaded in memory for us to be able to use. So now we can use the p5.js image function. So if we go over to our reference here and we load the image, you can see here that this is going to allow us to use that variable we just created and then render that image at some location. So the parameters here are, where are the parameters? I think it's just X and Y, right? Or is there a scale here? The second and third parameters, dx and dy, set the coordinates of the destination's image's top left corner. Okay. So we can also use image mode for other ways to position images. So let's experiment. Let's see what happens. So let's just try to use this image function using the image variable we just populated. But the question is, where do we put this? Where do you think we put this call to the image function? All right, hopefully you guessed it. We're putting it inside of the ship's draw function, right? So we're going down to our class ship. We're going into the draw method, and where we're drawing our triangle, we're going to take this out. I'm going to just comment it out for now. I'm actually going to comment out all three of these lines because we don't need any of them. Now, if we go to our program, there's going to be no ship. Nothing is happening. But now what we could do is we could say image. Make sure the autocomplete doesn't capitalize that image, because it's got to be under lowercase image, and it's going to be ship image is the variable we created. And now what is going to be the position of the ship? That's right, hopefully you guessed it there, this.xpos and this.ypos. If I could type pos. Okay, so now let's go ahead and look. And look at that, we have our ship flying around. And if we shoot, the lasers are way off, which is okay. We can adjust that. But our ship is moving around. Awesome. Okay. So before we modify the lasers, now let's do the same exact thing for our enemies, because we're going to have to do some coordinate adjustments to our enemies as well. So let's take a look at an enemy here. So let's go back into our, let's look at a couple of these ships. Let's look at something. What do we want to do? These guys look kind of like enemies, huh? These guys look cool, right? That's a cool looking enemy. I like that. All right. So a couple things here. We probably want to rotate this because the enemies are coming down on the screen. If we just rendered this like this, the enemies would be turned around. So there is a way to do this programmatically. We could do a translation and then translate these to turn them around. But I like to keep things pretty simple. What we could do here is we could just rotate this in the image and then call it a day. So let's go ahead and see if we can do this just with this. So I'm going to go ahead and see if I can remember how to do this in GIMP. Rotate tool, that's what I thought I was on. And we're going to go ahead and just rotate that bad boy. Now I'm going to go ahead and export this. I'm not going to put this in the same directory here, or you know what I will? I'll say rotated and export it. Now, you don't have to, obviously I'm using a different image editing program. I think most of you are pretty familiar and have access to Photoshop. You could certainly do it there. GIMP is an open source alternative to Photoshop. I'm a big supporter of open source communities and all of the things that we create in these communities. So yeah, check it out if you want. It's pretty cool. It's kind of like Blender, but for just image editing. Okay, so now we want to go ahead and grab that rotated ship, which is right here. And we're going to do the same exact thing. We're going to say, drag this and drop this right here. And this is planes 07A underscore 3 rotated. So you may have guessed it. The next thing we're going to do here is we're going to go ahead and create a new variable for enemy image. And we're going to say enemy image equals load image images / planes underscore 07A underscore 3 underscore rotated .png. Okay, now we're going to do the same exact thing with the ship, but we're going to put this in which class? That's right, the enemies class. All right, so let's go down to the enemy. And now here we're saying, hey, if you're alive, go ahead and draw this rectangle. We don't want to do any of this anymore. I'm going to go ahead and comment this out. Quick hint here to comment multiple lines like I just did. If you highlight those lines and hold Control and then hit / you can comment out multiple lines all at once. Again, us programmers are lazy and we want to make things fast. So we're going to do the same exact thing here. We're going to say image, and we're going to use enemy image, and we're going to do the same thing. This.xpos, this.ypos. Okay, let's see how it looks. Our enemies are coming down the screen. Nice. I gotta say, these assets are pretty cool. Actually, I feel like the hitbox is a little off. We can modify that distance, but the lasers definitely need to come down a little bit. But before we do that, I kind of want to get a laser image in here too. Those green dots are not doing it for me. So let's go ahead and do a little laser image. So let's go back here to our assets and let's grab projectiles. I'm kind of digging this one, and I think I opened this one already. Yeah, I like this. So what I'm going to do here is I'm going to crop out just one of these. I'm going to crop out the first one because I want to use this. So I'm going to crop that, and I'm going to export it, and we're going to just say edit. Okay. And now we have our edit. Now let's go here and upload this. And now muscle memory, right? We're going to do this again. So let's go ahead and go back up, and we're going to say var laser image. And then here we're going to say laser image equals load image. Now think about a larger game and how many different pieces of art that are loaded when a game is loaded, right? So next time you're playing a video game and you're on that loading screen and you're like, wow, this game's a little slow. Think about how much is being loaded when you're loading that huge, vast open world game with all of those 3D assets, all the materials that are wrapping around it. We're just loading 3 images here. There are thousands and probably millions of pieces of digital art that are loaded in these games. And it's quite amazing that teams of people come together and create these experiences that we all get to enjoy. So now that we have this laser image loaded here, now if we go down and go into our laser, we're going to do the same exact thing. We don't need to do this anymore. We're going to go ahead and take that out. And now we're going to say image, laser image, this dot xpass, and this dot ypass. Now I'm expecting that we're going to have to adjust these a bit to make sure they fit, but let's see what it looks like. Oh, that looks cool. All right, nice. So we have a cool laser going on. Hitbox is a little off, but not crazy. So the laser's coming out over here. It's actually pretty much in line. We just need to move it over a little bit. So the X position needs to be incremented a bit, right? So if we take this X position and let's go ahead and add, say, I don't know, 30 to it. I'm just making up a number there. Let's just see how that works. Oops. Did I introduce a syntax error? No, okay. Okay, we're getting closer. We're getting closer. So let's say 40. Well, yeah, 40. Ooh, that is close. Let's do a little bit more. Let's say 43. One less, 42. Now we could probably mathematically do this too, and like, yeah, that's actually perfect. Look at that. Now I know some of you are working on some backgrounds for this too, which I think is really cool. You know, like a star background or cloud background. Definitely, I will consider that an extra credit item as well if you want to draw a background. Probably not going to do that on this video, but as I'm playing this, I'm just kind of feeling like, hey, there should be a background here, right? But this is looking really good. All right, so that's kind of where we're at with the images. The images are coming in. We got our enemies coming down the screen. Everything is looking good. There are a couple of pieces that I'd like to kind of improve here. First kind of extra credit item here is to add a score to the game. So this one's going to be pretty easy because we just need to calculate every time we hit an enemy. If we hit an enemy, we increment the score, right? So how do you think we would do that? So we're thinking about a value that we need to store here, some type of value that will increment as we hit. So whenever we think of that, you want to think of a variable, right? We're going to need a variable to store the score. So to score the store. So we're going to go ahead and go up, and we're going to have another variable up here. And this variable, let's call it score. And we're going to start the score at 0, right? You're not going to start with any actual score here. Now, before we do anything with the score, let's go ahead and output it to the screen because by default, you're not going to see any score here. So maybe we'll put like a little score in the upper right or left-hand corner. But how do we do that? So let's go to P5.js. There is a function called text. And this function, where is the text function? There it is. So this draws text to the canvas, which is exactly what we need. So it's going to draw us some piece of text at some X and Y position. Perfect. So let's go ahead and just try to do this real quick. So if we go into our draw function here, before we do any ship updating, I'm going to go ahead and call text and make sure it doesn't capitalize. And we're going to say hi. And we'll draw it at, say, 10, 10. Now, we don't see anything on the screen, maybe because the default text color is black, and we can't actually see black on a black background. So we do need to modify the fill of the text. So let's go ahead and change that. So let's go ahead and make the fill. Autocomplete, getcha. Fill, and we'll make it white. There's our little hi. Look at that. Okay, so let's move it down a little bit so we can actually see it a little better. So I'm going to move it down, say 20. And there we go. It's kind of fitting there. Now, we want to make it a little bit bigger. So there's this text size function. So we can call text size. And let's make it 24. Let's see how big that is. Okay, that's pretty good. An itchy nose. All right, so what we're going to do here is we're going to say this is going to be score, colon, with a space. There we go. I'm going to move it down a little bit further just to give it a little bit more breathing room. Okay, that looks good. Okay, so now we need to actually output the score. So, you know what? I'm curious if we can actually include variables in this without, like, let's see if we could do this. I don't think we can. This is called concatenation. I'm trying to concatenate the variable onto this fixed string here. So, we can. Beautiful. All right, excellent. So instead of doing two calls to text, we could just put plus score, and this is going to, it's not going to mathematically add it together, it's going to concatenate it, which just brings these two pieces of information together. So I included a little space here so that they're spaced apart, and now we're outputting the score, but the score never goes up when we hit an enemy. So what do we need to do to increase the score? What do you think? How would we do that? So inside of the draw function, we are detecting the distance, and we know we hit an enemy. So when we hit an enemy, all we have to do is say score plus plus. And boom. Now, if we go here and we hit an enemy, whoa! We're getting a lot of points for hitting an enemy there, huh? Now, why do you think that's happening? Now, that's happening because that conditional statement is actually true as the laser moves through the size of the enemy. So every single pixel that it's moving through that enemy, you're getting points for. Now, we can kind of keep it like that for now. You can think about how maybe you would change that to just constrain the incrementation of that score to say, hey, if you hit the enemy, just increment the score once. One thought is that instead of doing it here, what we could do is because it's still going to call it here. So I have to think about that a little bit. But think about that. That could be a piece too here. But try to get that score in. That'll be the first kind of extra credit here, is to get a score in, which we have here. Nice. And this actually might be a cool dynamic too, because you get some pretty high scores, right? You know what could be pretty cool too is as the score goes up, make the speed of the enemies increase, or maybe even the amount of enemies increase, right? So like the speed that the enemies are coming down could be relative to the score. So like, I'm just kind of experimenting here, guys. So if we take the score and currently the enemies are moving down 1 pixel at a time, right? So if we take this and plus, let's say the score, right? So the Y position plus the score. This will be crazy because this is gonna go really fast, really quickly. So right now the score is 0. Actually, they're not gonna come down at all. So let's do this, score plus 1, so that it's always gonna be at least 1. So now they're coming down 1. Now watch what's gonna happen. Once we hit 1, boom! Now it's gonna get really hard. They're going too quick. And eventually, if we can even hit another one, now they're gonna be like the speed of light. So that's not gonna work. So we have to scale down score a bit. So why don't we scale down score by, say, 1,000. And I'm just simply dividing it just to make it smaller. Now when we hit this, they're incrementally getting faster, but not at a rate that's like unsustainable. See how they're getting a little faster, We can even And this will be an extra credit item too. So extra credit item number 2 is to make the difficulty of the game dynamic based on the score, right? So now they're going pretty quick now, but now that they're going pretty quick, they're pretty spaced apart. So I'm thinking not only does should the speed change, but maybe the frequency at which we generate ships should change, right? So how would we do that? If we wanted to also make the ships come down in a more frequent fashion, if we go up to our draw function here, where we say frame count mod 1, maybe we decrease this by the score. So it will start to, this may not work very well, but let's see. If we say mod 100 minus the score divided by some scale value, right? So we're going to really scale down that score considerably and subtract it from 100 frames. This is going to eventually get us to be generating a ton of enemies, I think. Let's see. We need one more parentheses here. Let's see what happens. Or just going to make it not generate enemies at all. Okay, well that's not working. How about ship? Like if we do it every 10 frames, let's just hard code this and see if this should be a lot of ships coming down, right? Yeah, so now we got a ton of ships coming down. This is just getting crazy. And they're going to come faster and faster. Ah! there is a little bit of math we can do here to make this scale down. I'm not going to focus on this too much in this video, but that is an idea. We can go ahead and try to modify this based on the score. Just a little experiment that you could do there. Okay, so we have all of our assets, we have a score, we have a dynamic speed system in place. Awesome. Now, a couple things. We want to be able to remove things from our system as they're not needed anymore. So this was brought up a couple times, and I want to highlight how we would do that. So just to frame the problem a little bit, if we say shoot these lasers, now those lasers that I just shot, although you can't see them, they're still in that array that we created here. So that's a problem because these lists, and the enemies are the same way, these lists are getting larger and larger and larger over time. So if I just let this game sit here, say I take a lunch and I come back, the game will have thousands of enemies in the system. It won't have as many lasers because I won't be shooting, but you get the point. These lists are going to get larger and larger and larger over time, which eventually the computer is going to say, hey, this is too much information. I don't know what to do here. And these loops that we're doing, so every frame we're looping over every single one, those loops get larger and larger to execute, which slows down our program. So how do we solve for this? So what we can do is we can essentially remove items from the arrays when they're not needed anymore. Now this is a JavaScript piece, and there's a function in JavaScript specifically on the array object called splice. And this is going to allow us to remove things from an array at a certain index. So this is the third piece of extra credit here to get the splice working. So how do we do that? Let's go ahead and let's look at our code here, and let's just think about areas in the system where we can detect whether or not we need the actual asset that we're talking about, either the enemy or the laser, which is really the two pieces we need to manage properly here. So I think the obvious piece is that we know when we hit an enemy that the laser is also most likely going to get destroyed, right? So we don't want these lasers just flying through the enemy. So whenever we say the enemy.alive equals false, we also want to remove this laser from the list of lasers. Now, instead of making it alive or not in a laser, what we can do is we can simply use the splice function to remove it. So here, I'm going to say ship.lasers.splice. Now we have this splice function, just like we have the length property that we've been using, right, up here and here. This is now a method that we're able to call, and we need to give it an index in which we want to splice. So just as we see here, there's an example here. There's a lot of different ways to use this function. There's ways to actually put things into an array, take things out. So definitely recommend you kind of looking at this a little bit. But you can see here, remove one element at index 3. This is calling the first parameter the index we want to remove and how many elements we want to remove. So we always want to remove just one element with what we're doing here. So we're going to say at index j, just remove one element. Now, this should take this out of the lasers array, this specific laser, so that when we loop over the lasers again to draw them, it shouldn't be drawn. So let's see what happens. Now these lasers will live. Now let's go ahead and hit this guy. And look at that. Boom. Lasers are gone. They hit them. And oh, look at that. So, haha. Notice how some lasers are just disappearing. That leads us to our second problem. Now these lasers, not only are they visually coming off the screen, but technically they're coming out of that array list, which is super helpful for memory management in our program. But you'll notice, look at some of those lasers just magically disappearing. Why do you think that's happening? Now, remember, we're just setting this alive to true or false here. We're not actually removing the enemies from the screen. We're just not drawing the square. Logically, it's still there. So we would have to do the same exact thing to these enemies. But instead of doing it here, why don't we do this? Why don't we actually convert this to a function or a method on this enemy, and we're going to call this method. So inside of our enemy, we're going to say explode. And I'm going to give this, because we're going to work with this global array, which I'm not crazy about this design, to be honest, but it'll work for the purposes here. I'm going to pass in an index value called I. And that's going to be the specific enemy that we're going to be exploding in the enemy list. Now what we could do here is we could say this.alive is equal to false, which is going to go ahead and remove this enemy from actually rendering. And now we're also going to say enemies, there's going to be no this on this, sub enemies.splice at index I 1. And this is going to remove this specific enemy at this I point from the enemies list. Now we can think about this. We can think about maybe rendering some type of explosion here that would render to the screen. We would use a different image. We would bring in a completely different image and then render it there. But let's see if this works. Now, in order for this to work, we do have to call it. So let's go back up here. And now instead of doing this, we're going to say this.enemy sub I dot explode, and we need to pass in this I here into the explode. And let's see what happens. And boom, now if we shoot in the same area, notice how we don't have any empty spaces here. And look at that. That also fixed our, whoops, something crashed. Cannot read properties of undefined XPath. Ooh, so try to index something that wasn't there. Let's try and run that again and see if we can reproduce that. So that fixed our score issue too, because the second we hit an enemy, it goes away. So it can't just roll through the ship. And notice how the laser list is not getting bigger and bigger. It's able to get, once it hits, it's getting smaller and smaller. But we still have a problem, because the lasers, if they do not hit an enemy, they keep going on, and so do the enemies. The enemies will just keep going on and on. But we just hit the crash again here. So let's go ahead and see, where are we crashing? So we're splicing this here, but we're using the length here. So what's happening is probably the length is not updated when we remove it from the array, which is then causing us to index a ship, a laser or an enemy that does not exist, which could be a problem. So how would we solve for this? Let's think about this. Okay, so we are hitting a problem here where we're trying to remove the enemies from the enemy array, and it's not working for us. It's crashing. So we're seeing a crash pretty frequently as we shoot our lasers out and we hit enemies. We're getting this. Cannot read property undefined reading splice. So what's happening here is that we are modifying the size of this array dynamically as we're inside this loop, and it's referencing an enemy that is not there anymore. So what we need to do is we need to, there's probably a bunch of different ways we can do this, but I think what we could do here is, instead of doing this complete splice of the enemy here, I'm going to take out this index in the explode method. I'm going to go down to our explode method here, and I'm going to remove this I, and I'm going to remove the splice here. So this explode essentially is just doing the this.alive equals false. You know, we can put some type of explosion image here. You could try to do that. That would definitely be extra credit if you put some explode in there. And so with that being said, how do we fix this? So now with this in this current state, we're back to our original kind of like, hey, this is going to disappear, but we're still hitting that enemy there because it's still technically on the screen. It's just we can't see the image. So what I'm going to suggest is, outside of this loop, so outside of the enemy's loop here, we're still inside the draw function, but right here, outside of this loop. So you definitely need to pay attention to the curly brackets here. You need to be outside this loop. So after everything is done looping over every enemy, we're going to create a new function, and we're going to call this function something kind of like clean unused assets, right? So we could say, hey, clean unused assets. And you're going to see quickly why we want to call it this, right? Because we don't want to just remove the enemies, but we also want to remove the lasers when they're off the screen. So let's go down here, and outside of any curly brackets, so again, this is a new function, so you want to pay attention to those curlies. We're going to write a new function called clean unused assets. And now essentially what we're going to do here is we are going to loop over both the enemies and the lasers, and we're going to check to see if either should be removed from their respective arrays. So how are we going to do this? It's going to be two loops, not nested loops, just two separate loops, and each loop is going to go ahead and check whether or not we should remove these items from the array. Now, some programming languages actually have these types of features built in, but on a much more technical level, they're called garbage collectors, literally called garbage collectors. And what they do is they do exactly what we're about to do. They loop through all of the different pieces of information in a program, and they say, hey, is anything referencing this information? If it's not, get rid of it, free that memory up. So that's essentially what we're going to do here. This is like a little garbage collector that we're writing. So we're going to write our first loop, and we can go ahead and use I as our variable. So we could say I equals 0, and we're going to make this loop over all of the enemies. So we're going to say is less than the enemies dot length, and we'll go ahead and increment that by 1 because we want to loop through every enemy. So for every enemy, let's see if we should remove it. So this is super simple, right? Because we're already switching the alive flag. So all we have to do is say, hey, if enemy sub I, so the enemy that we're currently looking at in this loop, is not alive. So we're going to put a little not here. This symbolizes not. So we're looking for any enemies that are not alive. Then we're going to go ahead and remove enemies.splice sub I1 right there. So this will go ahead and remove that enemy from the enemies array, and that will clean the enemy off. Now with this here, we are calling this, right? So we're calling it here. So now as we fly around and we shoot, we should see visually it's doing the same thing, but technically it's actually removing that enemy from the list. So we don't have any weird kind of lasers just falling off the screen there. It's all doing what it should do. Awesome. Now what this also enables us to do is clean up our lasers in the same function. So what we'll do here is outside of this for loop, again, watch those curlies. We're outside the for loop. We can reuse the I variable because we're going to use it again. We could just reuse the values here. It's not like a nested loop where the nested loops, we need to have two different control variables. We don't need that here. So this is going to be ship.lasers.length. And we'll go ahead and increment through every laser. So this is going to be for every laser. Now, what we want to do here is we want to see if the laser, if it's still around, because we're taking the laser off when we hit an enemy, but if the laser is still around and we didn't hit an enemy, it's going to be off the top of the screen. So the conditional that we can write here is super simple. We could just say if the ship.lasers sub I dot ypos is less than 0, that means that it's off the top of the screen. Then we're going to say ship.lasers.splice, and we're going to splice that I off, and we're going to splice 1. Now that should remove the lasers from the screen. Now visually, this is going to look exactly the same, but technically, it's going to be removing that laser. Notice the laser array we're console logging here. There's only about maybe a half a dozen lasers here. Now if I shoot one laser, there you go. You got one laser there. And now you have two lasers. Now if I go ahead and shoot one more, there's only one laser there. So the lasers are now being removed from this list as they go off the screen. This is going to make the performance of our game so much better, because now if there's nothing on the screen, then there won't actually be anything in those arrays. Now there's one piece that we're missing here. The enemies, if they do not get hit and they're off the bottom of the screen, so they're still alive, like this guy down here, he just flew away. He's still in the array because we didn't remove him. So we can extend this a little bit further and we can say, hey, if the enemy is not alive or the enemy sub I dot ypos, ypos is greater than window height. We also want to remove it, right? Because if it's past the window height, then it's not in the game anymore. We don't see it, and we should take it off of that list. So again, this should look exactly the same, but now we're just managing this a little bit better. So if an enemy goes and flies off the screen, let's just get one down there. And let's make sure it just doesn't crash for some reason. We'll fly through enemies. Whoa. We can also do, and this could be another bonus, there's so many little things that we can do in this program to enhance this further. If we hit an actual enemy, do something like decrement the score, or maybe we introduce a life. So any little tiny incremental improvement you can make to this as you're developing this, I'm going to give you extra points for this, and we're going to enhance your grade with this. I want to give you guys as many opportunities as you can to get a better grade and really make this your own. right? Hopefully at this point you can see that there's all these different very creative ways we can go about designing these programs. There's no hard rule in terms of how you design these. Of course, there's syntax rules and there's definitely logic errors that we can introduce, and it will not probably work. As you see, even me, as I work through these, they may not work the first time you go about solving these issues, but if you keep keep at it, you're going to get it. And of course, if there's any questions you have, please ask me. But I think I'm going to end this here. I think there's a good amount of extra credit work that I've introduced here. We showed you how to go ahead and get your image assets in here. Another piece I'll throw in there, this is a bit more complex, and if for anybody that wants to learn how to do this, I'd be happy to extend this further, is to get a little animation in here. Like when I go left and right, these image assets, I do have an animated kind of tilted image of the ships. So we could do that. Things like the explosion animation, all that type of stuff, backgrounds. There's so much we can build from here. So get creative with it, play around. I'm sure it'll be a bit frustrating. There'll be sections where it's crashing on you, you're not knowing what's going on. Please reach out to me and I will help you with it. But yeah, I think that's it. We got a pretty cool game running here. Dig in these image assets, but please try to use your own and play around with it. These image sizes were about, what would we say, like 90 by 90 in terms of the size. Again, they are transparent PNGs. I'm not sure if I mentioned that actually. So transparent PNGs, so you'll have a transparent background. Where's the image size here? So yeah, 96 by 96 pixels. So that's the size of the image we're using here for both the enemy and the ship. All right, guys. I will see you next week. Have fun. Please reach out to me if you have any questions. Thanks.